Hi there! In this video, we're going to talk about segments and congruence. But before we get to that, we have to learn a little bit more vocabulary. So the first couple words we're going to talk about have to do with proving things and non-proving things in geometry. So the first one is called a postulate or an axiom. And it's a rule that we accept in geometry without proof, which means it's never been proven to be true, like with an actual mathematical proof, which we are going to learn how to do in this class. It's never been proven to be true, but no one's also ever proven it to be false. So it's something that we accept is true. There's not a lot of these, but there are some. Then the next thing is, which there are a lot of them, are called theorems, and I abbreviate them THM. And it's a rule that's proven to be true. It's been mathematically proven to be true with an actual math proof. So, first thing we're going to talk about is the distance between 2 points. So, how do I find the distance between 2 points? I have a little example here for you. In my line AB, which you'll see here, I have 2 points and I gave them a coordinate. So point A is at 27 and point B is at 50. And I want to find the distance or my length. In other words, how far is it between these two? 99.9% of the time, pictures are not going to be drawn to scale, so don't anticipate that they are. So what's the distance between A and B? So to find distance, okay, I use absolute value because remember, absolute value always makes everything positive, and it's impossible to have a negative distance. So I want to take my right point and subtract my left point. So I take my absolute value of my right point is going to be 50 minus 27. And I subtract, how much is 50 minus 27? That's 23. And the absolute value of 23 is 23. Now, if you always do right minus left, you're always going to end up with a positive number. But if you did left minus right, okay, that's why they have that absolute value, so you still end up with a positive number. Now mathematically, they're going to write this out. They're going to say, well, the absolute value of x2 minus x1, what does that mean? That just means in my line over here that A is going to be my first value point, and B is going to be my second. So they're saying, well, this x2, my second point or my right point is 50. And then my first point, my left point is 27. I subtract them. That's all that means. The other thing that you need to know is that you'll notice here, I wrote the length between my points, AB. I just named AB. I didn't write it AB with a line segment over it or AB with a line. Okay, when I have nothing over the top, that represents the length. Okay, next. Segment addition postulate. So the segment addition postulate has to deal with a line with a point somewhere in between. So you'll see I have this line segment, or I should say a segment with a point in between. So I have this line segment PR with Q that's somewhere in between. Now you'll notice when I have this Q cuts my line up, right? So I have this part, P to Q. I have this part, Q to R. And then I have my whole line segment. So I like to think of the segment addition postulate as the following. Small, my first small segment, plus my next small segment equals my big segment. And so you might think, well, I still don't maybe understand that. Let's just say this is 4 and this whole thing is 6. How much is my whole line? Well, my whole line, I have to add them together. How much is 4 plus 6? 10. So the segment addition postulate says I'm going to take my small part of my line plus my small part of my line, and it's going to equal my big part. So we're going to do a couple examples with everything that we just learned and then talk about one more thing. So first I want you to find the distance x, y. So what's the distance between x and y? So I'm going to write this out mathematically properly. So x, y, my length. I'm going to take my absolute value and I'm going to do my right point minus my left point. So 26 minus 14. 26 minus 14 is 12, and the absolute value of 12 is 12. But again, if you always do your right point minus your left point, then you'll always end up with a positive number. Okay, practice problem number 2, find a GH. All right, so I'm looking here and I notice that GH is my whole line segment. So in my segment addition postulate, it says that small plus small equals big. Now mathematically, they're probably going to write this out. They're going to say, well, GI plus IH equals GH. So how much is GI? Well, GI is 22. How much is IH? IH is 7. And I don't know GH, so I have to figure out what it is. So I put a line down the equal sign, and I can combine together my like terms. 22 plus 7 is 29. So now I know that GH is 29. I can use the segment addition postulate when I'm also given only one of my small segments to find the other missing one. So this one is saying find WX. I need to find this guy right here. So again, we know that small, I'll do it right here. Small plus small equals big. So what are my smalls? Well, VW is my small, so this one is 37. My other small I don't know. I'm going to call it X because it's a mystery to me. And my big one is 149. I'm going to zoom this over here so I have some space to work. So I have to get my X on a side by itself. And you might say, well, why are you writing an equation? I can just subtract it. You can, but I like to write out an equation for practice when it gets a little bit more tricky. So I need to get X on a side by itself, so I have to move this 37, so I'm going to subtract it from both sides. And there is no shame in using a calculator. If you can't do this in your head, don't even worry about it. 149 minus 37 is 112. So I get 112, which means this is 112. So my answer is 112. Okay. We're going to do the same concept here. We are missing a, whoops, I did the wrong thing. Sorry, I don't want you to find AB. I want you to find BC. Okay. We're missing a small. So I have small plus small equals big. Now my small, I have a AB, and my other small is BC, and my big is AC. So how much is my small, my first one? AB is 25. How much is BC? I don't know. I'm going to call this guy X because I don't know what it is. And my last guy, AC, is equal to 50. So plus X equals 50. I'm going to zoom this over here so I have space to work. 25 plus X equals 50. I need to get X on a side by itself, so I have to subtract 25 from both sides. And I get X equals 25. Ooh, it's equal. So that means it cut it in half. So let's talk about that. Congruent segments. When I have segments that are the same length, we say that they are congruent. So when I'm looking here, I'm just going to redraw my picture. If this is 25 and this is 25, I say that they're congruent. I show that they're congruent in my picture with a single dash like this. This line segment is congruent to this one. It doesn't matter what the length is, it just matters that they're the same. So if I didn't have a length to write, and I just had P, Q, and R, I can say that PQ is congruent to QR. And I would write this out like this. PQ is congruent to QR. Okay, if I'm looking over here, and we still called this PQ and R, we know that PQ, the length is 25, and QR, my length is 25. I can say that PQ, my length, is equal to QR because distances are equal, but segments are congruent. And remember, congruent is an equals with a squiggly over top of it, and equal is just a plain equal sign. So distances are equal, segments are congruent. Let me know if you have any questions. Good luck.